All right, ladies and gentlemen, here we are with the shorter Unit 1 test review. This is the Unit 1 test review that you were all given in class, and this is going to be a solutions video beginning with number 1. Now, in this solutions video, I'm going to show the answers, of course, but more importantly, how to get those answers, and perhaps parallel importance is how to show your work. So how to demonstrate that you know how to get those answers. All right, well, let's begin with number 1. Evaluate each expression, do not round. All right, so here we have negative 25 plus negative 2. When we add two negative numbers, the result will be even more negative. So the sum is going to be even more negative. So the way that you kind of show your work here is to just write this like it's an addition problem. Okay, so we have 25 and 2, and notice that I'm just leaving the negative symbols out right now, because I know that in my answer, whatever the answer is, I'm going to put a negative sign in front of it. Well, 5 plus 2 is 7. And 2 plus nothing is 2. All right, so the negative sign there goes with the 27. So negative 25 plus negative 2 is negative 27. So the way that we'll write that is we'll say negative 25, because we want to make a statement here, plus negative 2 equals negative 27. All right. So for those who thought there was nothing to do in terms of work, look, we were able to show work. And we want to box our answer so that we make this very clear to whoever's looking at it what the answer to the question is. Okay, moving on to number 2. We have an interesting situation. 18 minus negative 47. I think it's important that we write this without the parentheses. So let's just see what we have here. We have 18 minus negative 47, okay? Now, the reason I wrote it like that is because whenever you see two negative signs sitting next to one another like this, they actually join together and become a plus. So the two negatives make a positive. So we can write over that and just make a huge plus symbol. So you see what looked like a subtraction problem was actually an addition problem. So let's go ahead and perform the work. And so we'll just stack add 47 and 18. Okay. And here we go. So 7 plus 8. That's 15, so we'll put a 5 right there and carry the 1. And then 4 plus 1 is 5, plus 1 is 6, so I'm getting 65. And that's the answer. So 18 minus negative 47 equals positive 65. Okay, and we'll put that minus that negative 47 in parentheses there. All right, so now we'll box our answer. And move on to number 3. Okay, so here we are again adding two negatives. So we're just going to perform addition without the negative symbol. symbols, and then at the very end, we'll put the negative symbol back. Okay, so let's start by writing out 94.875. And the alignment on this problem will be with the decimal point. So I'm going to think about my place values here. I've got 50.7, and I'm going to put the 50 here under the 94, and then put the decimal, and then put 7. And if it helps you, you can write in some zeros so you know what you're adding, okay? So now what we're going to do is draw a long one with a longer left tail there. See that? That way I can put a plus right here, make it look like a math problem. And now we're just going to proceed with our addition algorithm. 5 plus 0 is 5. 7 plus 0 is 7. 8 plus 7 is 15. So we'll write 5. We'll bring down our decimal point, and then we'll put a 1 there to carry with the 4. 4 plus 1 is 5, plus 0 is 5. So I just have 5. And then 9 plus 5 is 14. So I'm just going to put 1, 4. So it looks like my sum is 145.575, and that's negative. Okay, so we'll just go ahead and box this up instead of writing it all out again. And there we go. All right, here we are on number 4. Now take a look at this. This can be confusing. What we have is we have negative 91 with some change. It's almost negative 92. Plus 25.3, okay? So because what you do in a situation like this, when you have a negative and a positive, is you look at the numbers and the signs, you say, which sign, negative or positive, is associated with the bigger number? And that's the sign that's going to be in the final answer. So this is going to be a negative number when we're done adding it. Now, the way that you add a negative number to a positive number is more like subtraction. So we're just going to subtract 25.3 from 91.98 and then make the answer negative, the difference, okay? So first let's write it out. We're going to write 91. Just remember at the end we got to put a negative sign. 0.98. And then we're going to say minus 25.3. And just make sure that you are lining up your decimal points. Okay. All right, and if you want to, you can put the 0 here. I keep writing it in blue because it's not really there. And when we start talking about significant digits, the lack of that 0 might become important. So, but for now, it doesn't matter. And let's just proceed to subtract. 8 minus 0 is 8. 9 minus 3 is 6. Bring down the decimal point. I cannot subtract 5 from 1, but I can borrow from the 9 and make that 9 an 8 and make the 1 into an 11 by adding 10. Okay, so now I'm taking 5 from 11. I'm allowed to do that, and 11 minus 5 is 6. 8 minus 2 is 6. And we just put the negative sign. Okay? So that's the answer. Negative 91.98 plus 25.3 We moved to the right on the number line, and we have a less negative number for our difference, but still negative. Okay, so we'll put that in a box. All right, so we kind of got done with the trivial problems, and now we're moving on to some stuff that can be confusing. All right. It says here, evaluate each expression. Express the answer as a mixed number if applicable. All righty. Well, first, I'm going to go ahead and rewrite this addition problem without the annoying and confusing parentheses. So first, I'm just going to rewrite -2 and 7/8 plus, and I'm intentionally leaving some room right here, plus 1/7. Okay? Now, we're in a kind of a similar situation where we have a negative number and a positive number. They're being combined, and it's no different than the decimals that we were working with before. So we're going to go ahead and subtract 1/7 from 2 and 7/8, but our answer will be negative. Okay? So here's how that works. First, we have to find a common denominator between 8 and 7. Now, if we know what our multiples of 8 are, and we know our multiples of 7, we know that the first time the multiples are the same is at 56, which for 8 means we're going to have to multiply by 7, and for 7 means we're going to have to multiply by 8. Now, how do we do that? We can't just multiply the denominator by 8. We have to multiply, because we're only allowed to multiply by a fraction that's reducible to 1. So we're going to multiply by 7/7. All right. Now over here with the 7, we're going to multiply by 8/8. All righty. So now when we multiply fractions, let's parcel this off here. When we multiply fractions, we multiply across the top and across the bottom. All right, you don't do that when you add, but you do that when you multiply. So the -2 just comes down, and we're going to write equals. So we're going to say -2. 7 times 7 is 49. And 8 times 7 is 56. Okay, and it says plus. We'll keep the myth of plus alive, even though we know we're going to subtract. 1 times 8 is 8. 7 times 8 is 56. All right, now what you're going to do is subtract 856 from 4956. Okay, so that's what you're going to do in reality. In the math problem. So in side work, what I'd like to see is I'd like to see 49 minus 8. Okay, 9 minus 8 is 1, and 4 minus nothing is 4. So that gives me 41. So my answer, my final answer, that 41 goes over 56, is going to be equal to -2 and 41 over 56. Okay, and that is my final answer, expressed as a mixed number. All right, so that's number 5. Moving on to number 6. Number 6. Okay, so what have we got going on here? I spy 2 negative numbers. See, we have -2 and -3 3/4. So we're really going to just be adding, but our result will be negative. Okay, so we have, let's write it out without the parentheses. We have -2 plus -3 and 3/4. Now, there was some confusion, like what to do with this. And you can just add this together, okay? I mean, if you just look at it and think of it like money, you got, $2 plus $3.75, right? So that's going to be $5.75 or 5 3/4, right? So, but it's going to be negative. So this equals -5 and 3/4, 3/4. You want to think of it like that, okay? And that's pretty much all the work you can do for that problem. All right, and we're moving on to number 7. Evaluate each expression. Express the answer as an improper fraction if applicable. So this time you're actually being asked to express it as an improper fraction. Boy, I see a lot of negative signs here. Let's write it out and see what it looks like without the parentheses. I got -7/5 minus negative. So there's my double negative. 1/7. Okay, well, the first thing you need to do is go ahead and make this a plus symbol. So that's a huge plus symbol right there. And so now we're adding a -7/5 to 1/7. So before we can actually determine the relative magnitudes, we actually have to find a common denominator. I can't really tell yet if -7/5, I mean, I can, you could too, but without a common denominator, it's difficult to compare the fractions, all right? You might be able to tell that the bigger number is going to be negative because it's already improper, which would indicate that there's a whole number in there and this is 1/7. But if that's confusing, just go through the procedure of finding a common denominator and you won't go wrong. So the common denominator we're going to look for here is going to be 35 because that's the least common multiple of 5 and 7. And in order to get 5 to turn into 35, we've got to multiply by 7, but I can't multiply by 7. I got to multiply by 7/7. So I'm going to multiply -7/5 by 7/7. And I'm going, in order to turn 7 into a 35, I'm going to multiply by 5/5, or 5/5. See, these numbers, these fractions that I'm multiplying by, they reduce to 1. And that's why I'm allowed to do this. Otherwise, I wouldn't be allowed to do this. It'd be against the rules. So now let's go ahead and put these in parentheses here so we know what we're dealing with. And we are going to multiply across the top and across the bottom, across the top and across the bottom. Okay? So let's see what that becomes. We have a -49 over 35, okay, plus 1 times 5 is 5 over 35. All right, so it should be obvious at this point that the bigger number is the one with the negative symbol. So what we're going to do is subtract 5 from 49, and then we're going to put a negative sign in front of that and put it over 35 and call it a day. All right, so again, side work for this, to the extent that there is any, would just be subtracting 5 from 49. And I do want to see all of the steps. 49 minus 5. Okay, so 9 minus 5 is 4, and 4 minus nothing is 4. So what I'm going to end up with is negative 44 over 35. And it wants us to leave it as an improper fraction. So this is going to equal negative, and then we're going to put 44 over 35. Okay, so that's your final answer there. And we're going to put that in a box. Okay, perfect. Moving on. We are going to subtract 3 halves from 1/7. Again, if you think about it, you can already tell that the larger magnitude number is the negative number. But let's get common denominators, because why not? All right, we're going to need it anyway. 7 and 2, the closest, the least common multiple is going to be 14. So once again, we're just going to multiply 1/7 by 2 over 2 and 3 halves by 7/7. So let's just go ahead and write that out because we don't have a lot of room. I want to show you something. Sometimes if you want to sort of direct the reader, you can put an arrow, okay, like look over here, you know? And so I'm just going to rewrite this now. 1 over 7. And it says minus 3 over 2. Okay, perfect. Well, now I'm going to multiply 1/7 by 2 halves, because I can only multiply by a fraction reducible to 1, so 2 over 2. And then I'm going to multiply 3 over 2 by 7 over 7. 7/7. Okay, and what we're going to do is we're going to go ahead and just group these real quick. We'll worry about the negative sign later. And we are going to multiply across the top and across the bottom for both of these. And the result will be here. We'll just go ahead and put an equal sign right here. Well, 1 times 2 is 2. That's big news. And 7 times 2 is 14. Let's go ahead and put that minus sign in. 3 times 7 is 21. Over. And then 2 times 7 again is 14. So now that we have common denominator, we can compare the relative magnitude, and sure enough, the negative is the bigger one. So what we're going to do is we're going to subtract 2 from 21 and write the difference over 14 and then put a negative sign in front of it. So the side work, which I guess we could put to the left on this one, the side work over here is just 21 minus 2. And I do want to see this side work. Again, the ability to do the problem in your head is good. So having that number sense is good. But let me tell you where that's, there's a place for that. And the place for you doing mental math is in the UIL competition called Number Sense, because that's the whole competition. You're not allowed to use a calculator. You're not allowed to use a pencil. You have to do all the computations in your head. But in this class, this is more of a writing class. It's not a math class. It's a writing class. I want you to be writing down everything. That way I can see your thinking. I can look at your work and say, aha, I see what this person was thinking. That's what you want to do. So you want to make it super obvious to everybody. You can't take 2 from 1. So we're going to borrow from this 2 right here, and we're going to make this 2 into a 1. And we're going to add 10 to this one right here and make 11. Now, 11 minus 2 is 9. And 1 minus nothing is 1. Remember, our result is going to be negative. So we're going to write 19 over 14 and then put a negative sign. So it's negative 19/14. So let's put an equals sign here. Equals negative 19 over 14. Okay, there's your answer. And we're going to put this in a box. I do want to give a shout out to a former student named Jay who gave a name to that red box. He called it the red box of correctness. So, Jay, if you're out there, what's up, man? And we are passing the torch of the red box of correctness on to a new generation. Okay, moving on. Write each as if this is number 11, ladies and gentlemen. Number 9, ladies and gentlemen. Number 9. Write each as a percent. Round to the nearest 1/10 of a percent. Okay. Well, how do we take a number and turn it into a percent? The technical answer is that we multiply the decimal by 100. Okay? Another way of saying it that's even more confusing is we multiply the decimal by 10 to the power of 2, 10 squared. But my goodness, that's confusing. Here's what you really do. You put your pencil on the decimal point and you just move it to the right 2 places. You see that? So now the decimal point is between the 2 ones right there. So I just turned that decimal into a percent. So let me do a little angled arrow here. And what I'm going to do is I'm going to say 0.611 equals 61.1%. Okay? 61.1%. And that's it. That's the answer. The work that I want to see is that right there. Okay, I want to see the movement of the decimal point. And we'll go ahead and put this in the red box of correctness, 61.1. It says round to the nearest 10th place. Well, we didn't have anything to work with there, so there was no hundredths place to examine for the rounding. We just leave it like that. And looking here at 0.42 on number 10. Well, okay, this is even easier. I take my pencil, put it on the decimal, and move the decimal 2 places to the right. So just go whoop, whoop. And in this case, I have a whole number, percent. So I just took 0.42, turned it into 42%. So let's write that out. Okay, so what we'll do is we'll say 0.42 equals 42. And I don't know what this is going to look like when you're putting it in CUDA. 42%. Okay. When you put it into the software, though, I should probably put an or here. You might see 42.0%, because it said round to the nearest 10th of a percent. So it's possible. I'll accept either answer, quite frankly, but I'll just write both down. You know, when you're in a science class, math isn't quite as important for this, but in like a chemistry class, physics class, biology class, significant figures are everything. So I just don't know what CUDA is going to show you. One of the two. Moving on, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen and women, workers of the world, we're on number 11. It says, write each as a fraction. Show intermediate steps if reducing the fraction is required. Okay, so basically that just says, show all your work. Okay, so turn 4.8 into a fraction. Well, here's how you do that. Take a look here at the 8 and tell me, what is the name of the place value? Well, that's called the 10th place, okay? So if I wanted to write this as a fraction, I'd write 4, and then the word and goes in place of the decimal, 4 and 8 tenths. That's exactly what we're going to write. We're just going to put an equal sign right next to the actual type thing and put a big 4. And then we'll say 8 tenths. Now you do want to reduce that, okay? So you have to think about 8 and 10 and say, what is the greatest common factor of 8 and 10? And the factors of 8 are 2, 2, and 2. The factors of 10 are 5 and 2. So prime factored. So the greatest common factor is 2, which means I can divide the top and the bottom, also known numerator and denominator, both by 2. Okay? And I do want to see this intermediate step. If you just cross the numbers out and write down 4/5, well, okay, but I would prefer that you show me the greatest common factor so that I know that you know exactly what you're doing. So we're going to put tiny little equal signs here so that we see, well, 8 divided by 2, that's going to be 4, right? And 10 divided by 2, that's going to be 5. So it's 4/5. So my final answer is going to be 4 and 4/5. Okay, see, now that work is written there, if you came back to this problem in 25 years to show your child how to do this problem, you would be able to see what you did and explain it to that younger student. So there's a reason. I mean, we show our work so we can explain it to others. Moving on to number 12. Okay, this is looking really complicated. We have 7.075. Well, tenths, hundredths, thousandths. So what I have, you're going to examine that last place there. That's the thousandths place. I have 7 and 75 thousandths. So that's going to be over 1,000. Okay? And now it's just a game of reduced by the greatest common factor. Now, any number that ends in 5 or 0 is divisible by 5. But is there a greatest common factor? There is. But I don't want to blow your mind yet. It's 25. You could divide 75 by 25 and get 3, and then divide 1,000 by 25 and get 1/4 of 1,000, which would be 250. and see, I'm confusing myself. Okay, so it might, I can't tell, I can't remember, honestly think. So what I would do first is I would just divide by 5, okay, because I know how to do that. So let's just divide by 5, and we'll kind of whittle down the number. So yeah, even mental math, again, don't try it. Okay, so this is easy enough. So now, just little equal signs here. So we're going to reduce it twice. Who cares? 75 divided by 5. Well, let's see. 5 goes into 7 once, and with the 2 is a remainder, so we stick that with the 5. 5 goes into 25 5 times, so 1, 5. So 75 divided by 5 is 15. Okay, and what's 1,000 divided by 5? Well, try to think about something you know. What's 10 divided by 5? 2. What's 100 divided by 5? 20. What's 1,000 divided by 5? 200. You just keep adding a 0, so this can be 200. Okay, yeah, my intuition was wrong earlier. Yeah, I'm glad that we did it this way. Okay, so now I notice again that I have two numbers, both of which end in 5 or 0. So I'm going to go ahead and divide by 5 again. And because we've divided by 5 twice, 5 times 5 is 25. That would have been the actual greatest common factor. But you know what? It just doesn't matter, because we're still going to get to the same result. It's just taking us a little longer. And sometimes the scenic road is the best. The Blue Ridge Mountain Byway or Skyway in Virginia is one of the most beautiful roads in the world, and it runs alongside a much faster highway called 81. But I do recommend taking the scenic road when possible. Don't try before you deny. Okay, 15 divided by 5 is 3. And 200 divided by 5 is, well, let's see, 5 goes into 24 times, so 40. So 3/40. Okay. All right, so our final answer is, no, I should just mention that 3 is a prime number and 40 has factors of 4 and 10, and 4 is 2 and 2, and 10 is 2 and 5, and so there's no common factors. This is fully reduced. So what we have here as our final answer is 7 and 3/40. And while you're on that Blue Ridge Mountain highway or skyway or byway, whatever it's called, across the spine of the Blue Ridge Mountains in Virginia, do visit Thomas Jefferson's Monticello mansion, palace, house, whatever you want to call it. It's worth the visit. Okay, moving on to number 13. Find each quotient. You can use long division, or you can convert to fractions and use, quote, KFC, keep, flip, change. I say multiply by the reciprocal. Some people say invert and multiply. But, you know, the kids these days, they tend to say KFC, keep, flip, change. But quite frankly, the better and faster way to do this, by far, is to just use it as a decimal. So here's what we do. We're dividing 2.5 by 0.1. So this is the dividend and this is the divisor. This goes underneath the long division symbol, and this thing goes to the left of the long division symbol. So we're going to write 2.5 divided by 0.1. Now, here's the deal. You can't divide by a decimal. So you actually have to move the decimal. You take the decimal and you just move it over however many places. In this case, you move it over one place to the right. But if you do that to the outside, if you do that to the divisor, you must also move the dividend decimal. So instead of 2.5, it becomes 25. So our problem kind of changed. We were dividing 2.5 by 0.1, but now we're dividing 25 by 1. So I do feel like we should probably we can use our arrow here, which is really cool. There's our arrow. Here's our actual division. 25 divided by 1. Okay, well, 1 goes into 2, 2 times. 2 times 1 is 2. Okay, there's no remainder, so we bring down the 5. 1 goes into 5 5 times. If this wasn't staring you in the face already, 25 divided by 1 is just 25. In fact, any number divided by 1 is just that number. So we'll go ahead and put that in a box, because that's the answer. And here we go. Uh-oh. So we're dividing a positive number by a negative number. It doesn't matter about magnitudes and sizes anymore. A positive divided by a negative is a negative. So a negative divided by a positive is a negative. A positive divided by a negative is a negative. And the same is for multiply. A negative times a positive is a negative. Doesn't matter. A positive times a negative is a negative. It's only a double negative that becomes positive. So positive times positive is positive. Positive divided by positive is positive. Negative divided by negative is positive. Negative times negative is positive. I hope that clears that up. So this is the dividend. Here's the divisor. Why don't we save ourselves some trouble and just move the decimal points before we begin? So instead of taking 0.1 and dividing by negative 0.5, I'm going to be taking 1 and dividing by negative 5. All right. So in this case, I actually just want to show, remember, you can write the division symbol as a fraction bar. So this is equivalent to writing 1 over negative 5. Okay, so it's just negative 1/5. So this is equal to negative 1 over 5. And, you know, depending on what, when you go in to put the answer into CUDA, if it's a decimal that's waiting for you there, 1/5 is 0.2. So it's easy with the fifths. 1/5 is 0.2, 2/5 is 0.4, 3/5 is hold on, am I getting this right? 3/5 is 0.6, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8, and then you're at 5/5. So it's pretty simple to do the fifths. And here we go. So this is also equal to negative 0.2. So I'm going to say either answer is fine. And if you didn't know your fifths, you could just divide 1 by 5, and you would have gotten, you would have figured that out. All right, here we are on number 15. We're going to find some products. So it looks like we're going to be doing just a big multiplication problem. All right, so we have a negative times a positive, so we know our result, our product is going to be negative. So we'll just ignore the negative symbol for a minute and do the multiplication, then put the negative symbol back on the end. We're going to put the 2.875 on top because it has more digits, and then put 2.56 underneath it. And we'll have to keep track of how many decimal places at the end. We'll move the decimal place over 1, 2, 3, 4, 5 places at the end. So here we go. We are going to write down 2.875. And below it, we don't have to line up the decimal places when we multiply. So we're just going to, but we do need to stack the numbers properly. So these are three numbers. They're going to go right here, 2.56. 2.56. And we're just going to ignore those decimal points when we multiply. So here we go. We'll put our multiplication symbol. And let's begin. 5 times 6 is 30, so we'll put a 0 and carry the 3. 7 times 6 is 42, plus 3 is 45, so we'll put a 5 and carry the 4. 8 times 6 is 48, plus 4 is 52, so we'll put a 2 and carry the 5. And finally, 2 times 6 is 12, plus 5 is 17. So we'll write 17 at the end here. Okay, now we're going to be multiplying by this top number by the 5. So 5 times 5 is 25. We shift to the left one place and put a 5 here, carry the 2. 7 times 5 is 35, plus 2 is 37, so we'll write a 7 and carry the 3. 8 times 5 is 40, plus 3 is 43, so we'll write a 3 and carry the 4. 2 times 5 is 10, plus 4 is 14, so we'll write a 14 here. All right, now we're down to the 2 here, so we're going to multiply. So we're going to shift over one place, and we're going to start by multiplying. 5 times 2 is 10, so we'll put a 0, carry the 1. 7 times 2 is 14, plus 1 is 15, so we'll put a 5 and carry the 1. 8 times 2 is 16, plus 1 is 17, so we'll write a 7 and carry the 1. 2 times 2 is 4, plus 1 is 5, so we'll put a 5 right here. Okay, let's make that look more like a 7. You see why writing very neatly is important, because you've got to line up all these digits. So let's draw a big bar here and put a plus symbol, since we're going to be adding all these up. And I know some students like to put the extra zeros in, so I'll just add those in here. And now we're just going to start from the right and just stack add. So 0 plus 0 plus 0 is 0. 5 plus 5 plus 0, that's 10. So we'll put a 0 and we'll carry the 1. So 2 plus 1 is 3, plus 7 is 10. So we'll put a 0, carry the 1. Now 7 plus 3 is 10. And 5 plus 1 is 6, so that's 16. Or you could say 7 plus 1 is 8, plus 3 is 11, plus 5 is 16. However you want to do that, you're going to put a 6 and carry the 1. All right, so 1 plus 1 is 2, 2 plus 4 is 6, 6 plus 7 is 13. I'll write a 3, carry the 1. Now I got 1 plus 1 is 2, 2 plus 5 is 7. Okay, so there's my final, oh, you can't see it. There's my final sum. Now remember, we got to move the decimal place 1, 2, 3, 4, 5 places. So we're going to put the decimal point there to start, and then we're going to move it over to the left 5 places. 1, 2, 3, 4, 5. Okay, so the decimal point is going to go right there. Now, that means that our final answer is 7.36. Okay? The trailing zeros, if you want to know if they're significant or not, you look at the lowest number of significant digits. And here I see that we only have 2 decimal points, or 2 decimal places here. So I'm going to just put 7.36. Okay. And it's possible that on CUDA it'll say 7.360, but either one's fine. 7.36, good enough for government work. All right, and that is number 15. We're going to move on to number 16. And I forgot something. It's not 7.36. We forgot our negative. It's negative 7.36. Negative 7.36. Okay, because see, I almost forgot that negative symbol. Negative 7.36. Okay, moving on to number 16. We see that we're going to end up with a negative again because we have a negative times a positive. This time it doesn't really matter how we stack it because it's 2 digits times 2 digits, but I'm going to put the 7.2 on top if nobody minds. So I'm going to put 7.2 over 2.7. Okay, and we're going to multiply here. Well, let's begin. 2 times 7 is 14, so I'll write a 4, carry the 1. 7 times 7 is 49, plus 1 is 50. There we go. Now we're going to multiply by the 2, so we shift over 1 place. I'm going to be under the 0 here. 2 times 2 is 4. 7 times 2 is 14. Okay, so this line and a plus, and if you want to fill in that 0 space with a 0, fine by me. Now let's just stack add. Let's not forget the negative sign, and we are going to be moving the decimal over 2 places. Okay, 1 here plus 1 here is 2. So 4 plus 0 is 4. 0 plus 4, big brain time, 4. 5 plus 4 is 9, and 1 comes down. And we're going to move over 2 decimal places, so we're going to put the decimal point at the end and move it. 1, 2, right there, 19.44. Okay, so now in this case, I'm going to give you 2 possible answers. So 2 possible acceptable answers are negative. Remember our negative, because it's negative 7.2 times 2.7, negative 19.44. But if we're following the significant digits here, we'll only have to the 10th place. So I'll say or, because I'll accept either answer, negative 19.4. Rounded to the 10th place, okay? Either one's fine with me. Okay. And that's all she wrote for number 16. We are flipping the page. So, a little break from hard math. It just says here on number 17, write the name of each decimal place indicated. There is no work to show. Okay. Well, it's hard to see, but there is a line underneath the 5 right there. So I need to write the place value. So this is the ones place. Then there's the decimal, and I got tenths, hundredths, thousandths, 10,000ths. So, oops. Well, what we're going to write down here is we're just going to write down 10,000ths. And I'm sorry that I'm left-handed. I'm obscuring the writing. I'll move my hand in just a second. Almost done. All right, so there's 10 thousandths, and we just need to put the T there. Okay, so there's 10 thousandths. That's the answer. No work to show. Okay, and we're ready to move on to number 18. Okay, so this time the line is under that 0 right there. Well, that's in the hundredths place. So we're just going to write down hundredths. Hundredths. It's hard to say those, huh? Those Nordic words, those Anglo-Saxon words there. Hundredths. All right, so we'll put that in a box. The red box of correctness. Thank you, Jay. All right. Okay, and we're moving on. It says here, write each as a numeral. In other words, convert the words into a number. There is no work to show. Okay, well, this can be deceptive. And if you got to pay attention, all right? 79,644 million. There's a couple ways to go about this, all right? Here's how I would go about it. I would start by writing a decimal point. This is millionths, not millions. So this is going to be a decimal. There's not going to be any whole number. So remember, we got the tenths, the hundredths, the thousandths, the 10 thousandths, the 100 thousandths, and the millionth. And now I'm going to write the number backwards, okay? So I know I got 44 millionths, so I know that I'm going to put 44 right here. Okay, so that 4 right there is in the millionths place, and it was 644 millionths. So that means this is a 6. So let's just double check. Yep, that's right now I've written down 644 millionths and then 79,000. So I'm going to put the 9 here and the 7 here. So let's see if I have it. 79,644 millionths. And I have a blank space right here. What do you think is going to go there? If you're thinking a 0 goes there, you are correct. Bingo. So I'm going to go ahead and write this out again, just for clarity, without the spaces. 0.079644. Okay, and before I put a box around it, let's make sure that we didn't, make a mistake. Okay, so let's do a spot check on this. 79,644. Well, what position is the 4 in? Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millions. Looks good to me. Put a red box around and call it a day. Red box of correctness going around you, Mr. 79,644 millionths. And we're ready to move on to number 20, okay? 900,752 millionths. Okay, so we're still in the millions. By the way, if because some people were writing like this first part and then a decimal. If there was going to be a decimal, you would put down, you would see the word and. Okay, so it would literally say 900,000 and 752 millionths. And then you would definitely have 900,000 to the left of the decimal and 752 millionths to the right of the decimal. But the absence of the word and A and D. That doesn't appear here. That means that we're dealing with a huge decimal. Okay, so start with the decimal, move over tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. And let's begin with writing going in reverse. I'm going to say 52. So this is a 2 and a 5. So I've got 52 millionths, 752 millions, 900,000. Okay, so think about what that's saying for a minute, all right? So that's saying 900,752 million. So you're actually going to fill up all these spaces, 900,752 millionths. Okay, that's it. So we filled up all the decimal places. So our final answer is going to be 0.90075. All right. Do we have 6 digits? Yes. Okay. So we're in the millionths position. Put a box around it, and okay, we're done with number 20. All right. Number 21. Find each quotient. Write the quotient as a mixed or proper fraction. No improper fractions. Okay. All right, so we're going to be dividing a fraction by a whole number here, and it should be noted, this is very important, note very important, 2 equals 2 over 1. That's very important, okay? That's something you should keep in your mind. Any whole number can be written as a fraction by just putting a fraction bar and 1 in the denominator position. So let's go back to our problem. We have, let's rewrite this as 4 4/7. Okay, and in order to divide or multiply fractions, we can't use mixed numbers, so we're going to have to temporarily convert this into an improper fraction, and then when we're finished with our division, we'll convert the final quotient back into a mixed number. But remember what you do to convert a mixed number into an improper fraction. You multiply and then you add. Okay, so what we're going to do is do 7 times 4 plus 4. Okay, over 7. So I'm actually going to write that out. Other people might do that part in their head, but I'm going to write down 7 times 4 plus 4 over 7. Okay, because that's really what you're doing to convert the, and I know a lot of you do that part in your head, but I'm just showing all the steps because some folks are confused, and it's understandable because it's confusing. All right, what's 7 times 4? 7 times 4 is 28. So that's 28 plus 4 over 7. Well, what's 28 plus 4? 28 plus 4 is 32. So this equals 32/7. And for those folks at home who were doing that in their head, just check 7 times 4 is 28 plus 4 is 32 over 7. Bingo. Okay? Just making sure. All right, now, so now let's bring it over here. Let's bring our attention. We'll do a little arrow action here. We're going to say 32 over 7. Oops, almost wrote 37. 32 over 7 divided by, and I'm going to go ahead, if it's okay, and write 2 over 1. Okay, because remember 2 equals 2 over 1 divided by 2 over 1. Okay, so now here's where keep, flip, change comes in. I've until I became a math teacher, I never heard keep, flip, change in my whole life. What I was told to do is when you're dividing a fraction, I was told to, instead of dividing by this fraction, to multiply by the reciprocal of this fraction. Okay, reciprocal. And if you've never seen that word before, what I'm saying is reciprocal, R-E-C-I-P-R-O-C-A-L, reciprocal, okay? So the reciprocal of 2 over 1 is 1 over 2. And that's what you're doing when you're doing keep, flip, change, okay? So you keep, flip, change, K, keep the first one, F, flip the second fraction, C, change this division to multiplication. So when I say multiply by the reciprocal, that's the same thing as the keep, flip, change. It's just back in my day, that's what we said. So this is equivalent, okay? And here I'll give you another symbol you can use. You can do 3 equal signs to say like this is congruent to or equivalent to, and then we're going to write 32 over 7, and now we're going to put a multiplication sign. We'll put a dot there for that, and we're going to multiply by the reciprocal of 2 over 1, which is 1 over 2. Okay, now, some folks, the temptation is, and it's perfectly fine, to just multiply across the top and across the bottom. But I want to point something out. I want you to start thinking like this. Notice that here I've got 32, and here I've got 2. Okay? So we can do a little fraction reduction before we multiply. All right? That's allowed. So I can divide both of those by 2. Leaving behind on the 32, 32 divided by 2 is 16. 2 divided by 2 is 1. I've just made my life a lot easier because now when I multiply across the top, I got 16 times 1 is 16 over 7 times 1 is 7. You see, so I don't have to perform the reduction. If you didn't know to do that, you would have multiplied 32 times 1. You would have had 32 over 7 times 2 is 14, 32 over 14. And then you just divide by 2, okay? So you divide 32 by 2, you get 16, and 14 divided by 2, you get 7. You'd end up with the same answer, but start thinking like this, and you're making your life a little bit easier. Okay, final step is to convert this back into a mixed fraction. So here's how you play this game. How many times can you fit 7 into 16? 2 times. That's 14. And 16 minus 14 is 2, so there's 2 left over. So the answer would be 2 and 2/7. Now, when I do that, there are some students that just look at me and say, what? And so here's what's really happening. Let me see if I can show this. Here's what's really happening. We are taking 16 and we are dividing it by 7. Okay? 7 goes into 16 2 times. 2 times 7 is 14. And 16 minus 14 is 2, so remainder 2. And so here's how I compose my final answer. This part on top, that's the big number part of the mixed number. This remainder is the numerator part of the mixed number, and this is the denominator. Okay, so 2 and 2/7. All right, so I'm going to put that here. Equals 2 and 2/7. Down here. I wrote it down here, okay? All right. So now we're ready to move on to number 22. And because we kind of encroached on our space a little bit, I'm going to draw a line here just to make sure it's clear to separate that. Okay, so now divide 10/9 by -5/3. Please remember that the result will be negative. So we're going to just directly convert this here. So keep flip change. I'm looking crossways. I don't see any reductions or anything like that yet. So I'm going to write 10/9 times, and then flip the fraction, but just keep that negative symbol, 3/5. Okay. Now I see some reductions. I can cancel my 10 and my 5 and divide both by 5, right? And I'll leave behind a 2 right here and a 1 right here. But that's not all, folks. We can also cancel out this 3 and this 9 and divide by 3. So this will leave behind a 3 and this will leave behind a 1. And we just simplified everything before we even did our across the top and across the bottom multiplication. So 2 times 1 is 1. 2 times 1 is 1. 2 times -1 is -2 over 3 times 1 is 3, so -2/3. And I do want to show the full multiplication. There it is, -2/3. If you didn't know to cancel all that stuff and you're confused right now, let's go ahead and show it if we hadn't done it. So we got 10/9 multiplied by -3/5. Okay, so we're just going to multiply across the top. So that would be -30 over 9 times 5 is 45. Okay. Well, the greatest common factor of 30 and 45 is 15. So I'm going to divide the top by 15, and I'm going to divide the bottom by 15. And you might have whittled away at this using 3 or 5 or something, but this is the quick route. And so this will give my final result as -30 divided by 15 is 2, and 45 divided by 15 is 3. So again, we get the same answer, -2/3. However you got there, if you got -2/3, you got it right. All right, so now we're down to linear equations. Okay, so solve these linear equations, show every step. So what we want here, folks, is we want to get x by itself, and I like to get x by itself on the left side of the equation, but it doesn't really matter. We'll just go ahead and work the problem. First, let's try to get x by itself. I'm going to start by subtracting 14 from both sides. Again, I'm trying to get x by itself. Pardon me. So I got to subtract 14 from the right side to keep the equation in balance. I also have to subtract 14 from the left side. Now, these 14s, they kind of just cancel out. 14 minus 14, 0. But on the left side, I have a -12 minus 14. That's like saying 12 plus 14, but the answer is negative. So let's just add. 2 plus 4 is 6. 1 plus 1 is 2. And then put the negative sign there. Okay? And now it's, I want you to keep your equal signs lined up. So what I like to do is take my pencil and draw a very faint line through the equal sign so that I know where to put the equal sign right there. And now notice we have negative x. So we're going to put negative x. Well, we're close to being done, but it didn't ask us to solve for negative x. It asked us to solve for x. Now, something you should know is that if you ever get yourself in a position like this, the quick way to do this is to just say, well, if negative x equals negative 26, it stands to reason that positive x equals positive 26, and you'd be correct. But here's what's really happening. We have a negative 1. So if there's nothing written to the left of the x, you can presume that there's a 1 there. So we have negative 1 multiplied by x. Okay? So in order to unmultiply that negative 1, you would divide both sides by negative 1. Okay? Now, when you divide by negative 1, first of all, you're dividing negative 1 by negative 1 here. Cancel, cancel. X is now by itself. So we might as well write x equals... But when you divide any number by negative 1, it's like changing its sign. Okay, so negative 26 divided by negative 1, that's a negative divided by a negative. The result's a positive, right? So it's just 26, just like our intuition gave us earlier, 26. So 26 equals x, or, okay, there's a reflection property in mathematics, x equals 26. And you're typically going to see the x on the left, okay? So that's why I said earlier we prefer to solve for x on the left. But either one is totally correct. Like I said, it's a symmetry property, a reflection, so they're identical. 26 equals x or x equals 26. Either one's fine. Moving on to number 24. All right, this time we're solving for a letter R. So just treat the R like it's an X, and there's only one step to get the R by itself, and that is to get rid of this 21. And since it's a positive 21, we're going to do the opposite of positive, which is negative. So minus 21 on both sides of the equation. Okay, always on both sides of the equation. These are gone. R is now by itself. So R, bring down that straight line to help me with my equal sign. R equals 33 minus 21. So let's just do a little subtraction problem here. 3 minus 1 is 2. And 3 minus 2 is 1. So R equals 12. Okay. All right, so now we're doing proportions. So I said that you can use the butterfly method. Okay, this is another thing that I never heard of. I was always told cross multiply and divide. Cross multiply and divide. But butterfly is in fact the same thing as cross multiply and divide. And if parents are watching, what the kids are trying to tell you is butterfly means you make little butterfly wings here and here. And anybody pre-millennium, I guess, would just cross multiply and divide, but the kids call it butterfly today. So what that means is 3x equals 6 times 5, which is 30. So 3x equals 30. That's what the kids mean. So when I say cross multiply and divide, I'm saying 3 times x equals 5 times 6, right? That's, so now I got 3x equals 30. Again, my way is cross multiply and divide. What do I mean by divide? I mean divide both sides by 3 to get the x by itself. So this is what I think cross multiply and divide is better. More information contained in that than butterfly. But again, the kids like to use the phrase butterfly. All right, so x is going to equal 30 divided by 3, which is 10, so x equals 10. And we really should be checking these by plugging the x back in, but feeling a little lazy right now about that. But you really should be checking your work by plugging this x back in and say, well, 10 divided by 5 is 2, and 6 divided by 3 is 2, so yeah, that works. 2 equals 2. All right, here we go. Number 26. Oh, this is interesting. So now we have a coefficient in front of our variable. So again, if we're butterflying, this is cross multiply and divide or butterflying. All right. We could simplify this proportion, but it doesn't matter. We're just going to go ahead and do it. So we have 5m times 5, or 5 times 5m. I'm going to write it that way, 5 times 5m. Okay, and that equals 6 times 9, or 9 times 6, doesn't matter, 6 times 9. Okay, now 5 times 5 is 25, so we'll write 25m. And 6 times 9 is 54, so we'll put 54. Okay, now we're going to divide both sides by 25. So those 25s cancel out, and I've got m equals 54/25. And if they wanted it in the form of a mixed number, 25 goes into 54 2 whole times. 2 times 5 is 50, leaving 4 behind, so that would be 2 and 4/25 if they're wanting that mixed number. All right, so you know both of these are correct, so I'm just going to say put this box around the whole thing. It didn't specify what form to leave it in at the end, so just leave it in both forms. Oh boy, so now we're dealing with word problems. So this is a one-step equation. It says the wind blew away 42 of your muffins. That was 7/8 of all of them. How many are left? Okay. So the way I would do this is say 42 equals 7/8 of x. Okay? So in other words, it says that 42 was 7/8 of all the muffins. So I'm saying 42 is 7/8 of x, which is all the muffins. So think about this for a minute. The question's asking us how many remain. So let's keep in mind what we're finding here. 42 is equivalent to 7/8 of all the muffins. So when we actually find X, we're going to be finding the total number of muffins, and then we're going to need to subtract 42 to get how many are left. Okay, but we'll worry about that later. Most importantly is, how do you get rid of a fraction when it's in front of, when it's to the left of a variable? What you do is you multiply by the reciprocal, okay? So the reciprocal of 7/8 is 8/7. So you're going to multiply both sides by 8/7. And it's important here that you make sure to put 42/1 because you're going to be multiplying 42 by a fraction. So you're going to multiply 7/8 by 8/7. And on the left side, the same thing, 8/7. Well, look at this. I have 8 here, and diagonally off across this multiplication symbol, I've got an 8. Cancel, cancel. I've got a 7, diagonal, bottom, top, left, bottom, right. Cancel, cancel. The X is by itself, okay? So we have our little equation here. And we're going to put X equals... All right, so now, if you wanted to multiply 8 times 42 and then divide by 7, that's great. But I find that I don't like to do hard work for no reason. So I'm going to go ahead and cancel 42 and 7 because they have a common factor of 7. 7 divided by 7 is 1. 42 divided by 7 is 6. Okay? So now I just multiply, look at the denominators are both 1, so you can just forget about them. 8 times 6 is 48. So X equals 48. But just remember, this is the total. Okay? That's the total. So that's not the answer. You need to take 48 and subtract 42 to find out how many were left. So 8 minus 2 is 6, and 4 minus 4 is 0. So 6 muffins remain. Or you could say 6 muffins are left. Okay? Just remember, it said, how many are left in the question? All right? It did not ask you to find the total number of, it didn't say how many were there in the beginning. It said how many are left. So it's a little tricky. The answer is 6. All right, number 28. Your cousin gave you $6.03. That's pretty weird. I mean, just imagine somebody giving you $6 bills and then saying, hold on, and then going around and finding 3 pennies. But nonetheless, sometimes cousins can be weird. Your cousin gave you $6.03 with which to buy a present. This covered 3/4 of the cost. How much did the present cost? Well, let's write down what we're told. First, we're told that 6.03, when it said this covered, that means equaled 3/4 or 3/4 of the cost. So that we're going to say X. So X, I think sometimes it's really important. The cost, we're assigning that the letter X, okay? Now, it's asking how much did the present cost? Well, then I think in this case, solving for X will give us the answer. Okay, so we'll just drop a little vertical line there. So we have a situation. We have a decimal over here and a fraction right here. So I better convert this to I can either convert this to a decimal, but that'd be 0.75, pretty difficult math. Or I could convert this to an improper fraction. Let's do that. Okay, so inside work, over here in side work, I want to take, now notice that's 6 3/100ths. All right, so I got 6 3/100, like that. Okay, so improper fraction, 100 times 6 plus 3 over 100. So 603 over 100. Okay, I hope that's clear. So that's equivalent to 603 over 100. All righty, so let's come back and write this 603 over 100. Now we can bring this down and write 3 over 4x. Okay, so now to get rid of the 3 over 4, we're going to multiply by the reciprocal on both sides. So times 4 over 3 times 4 over 3. Now, let's first cancel out what we can cancel out. I got diagonal 3s and diagonal 4s, so cancel, 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 cancel. All this stuff goes away. X is by itself. And now it's very important because we don't want to multiply all this stuff out and divide. Notice something. Can you divide 100 by 4? Think about money. That's $1 divided by 4. That's 4 quarters. Each quarter is 25 cents. So if I cancel the 4 and the 100, that would leave behind a 1 here for the 4 and a 25 here. But we're not done. 603 is divisible by 3. Okay? So we can cancel the 3 and the 603, and we can divide 603 by 3. And you can do it in your head. 3 goes into 6 2 times. Then put a 0. 3 goes into 3 one time. So you got 2, 0, 1. So 603 divided by 3 is 201. So what I got left over is I got 201 over 25. Okay, but it asked us how much the present cost. It didn't ask us, so we're going to have to give money as an answer. All right, so here's how I'd like to think about this. Let me think about how I want to think about this for a second. I think we could just divide it. It should be okay. All right, so let's just take 201. We can do this. Divided by 25. All right, so 25 goes into 100 4 times. It'll go into 200 8 times. So we'll put an 8 here. So that's 8 times 25 should give you 200. And we're going to have a remainder of 1. So we're going to put a period there, decimal point, and bring out the division line. Invent a 0, bring it down. 25 won't go into 10, so that put a 0 right there. Invent another 0, bring it down. How many times 25 go into 100? 4 times. And there's your answer, 8.04. So I'm going to give you a new symbol now. You ready? Well, first I'm going to say 8.04 equals x. And now I'm going to give you a new symbol. Here's a cool symbol. You see these 3 dots? See those 3 dots? This literally means therefore. And the reason they invented those 3 dots is so you don't have to write out therefore. You can just put those 3 dots and it means therefore the present cost $8.04. Okay. And that is the answer. The present cost $8.04. Okay. All right. Moving on. Number 29. Solve each equation. Show every single step. Okay. Whatever. All right. Well, I like this. I like to rewrite my my problems out. Instead of like using the font size, I want to use my own font size. So I'm going to rewrite the problems. Okay, so yeah, I'm going to rewrite the problem because I'm going to use a little bit bigger font. We have 1 plus x over 6 and that equals -1. Okay, so this is something we haven't encountered before. I'm going to walk you through it. Don't worry, it's very, very simple, very straightforward. We're going to start by peeling the onion. We're trying to get x by itself, but first we got to get rid of this 1. Right now you could think of it as +1, so we're going to subtract 1 from both sides. Okay, -1 and -1. Okay, so we should probably drop our little line down here. Okay, now 1 minus 1 is 0, so you can just kind of cross that out like that. And we're going to go ahead and rewrite x over 6 right here. Practice that x, okay? It's not, here's how you write the x. If you're not used to writing it, it's this stroke here, like that, and then a straight line like that. That's the variable letter x. I want you to get used to writing that x like that. Again, let's do it again. That's like this, and then a straight line. There's your variable x. No, if you write this down as x, that means multiply. Now that you're learning these variables, you have to write the letter in this kind of cursive fashion, okay? Just something to keep in mind. All right, let's get back to the problem. We have x over 6 equals, keep your equal signs lined up on that nice vertical line. And now here we have the sum of two negative numbers. So what's -1 plus -1? Well, it's going to be -2. So this equals -2. Okay, and now here comes the confusion. Students get confused when they see this. They're not sure quite what to do. So I want to make a point of showing something in side work, just so it's clear what's going on, okay? x over 6 is the same thing, so that's equal to 1/6 times x. Okay, so now think about that like that. Actually, we'll go ahead and write that down. Let's go ahead and write down 1 over 6 times x equals -2. Now do you see what to do? So in order to get rid of the 1/6, you would multiply by the reciprocal. Keep flip change. So multiply 1/6 by 6 over 1. Okay? So since we're going to be multiplying the left side by a fraction, let's go ahead and turn this -2 into a fraction by putting a fraction bar underneath the -2 and putting a 1 here. Just so it's very clear what we're doing. Now, what we're going to do is we're going to multiply both sides by 6 over 1. Okay, we're going to do the same thing on the left and the right. 6 over 1. Okay, now on the left, I see diagonal 6s, so I can cancel, and it's not really, I mean, the 1s don't matter, but cancel, so you can think of them as going away. X is now by itself, so let's bring down our vertical line and say, all right, so now we're going to write x by itself equals, and now since we have 1s in the denominator on both of these fractions, they just don't matter. We're just going to multiply -2 times 6. Well, 2 times 6 is 12, so -2 times 6 is -12. X equals -12. All right, there's your answer. We'll put that in the red box. Okay, does it pass the smell test? Well, -12 divided by 6 is -2. -2 plus 1 is -1, and -1 equals -1. So yeah, if you plugged in the -12 for the x, then it would all work out. And so x certainly does equal -12. All right. Now we're moving on to number 30. Okay, so we have 7 minus 6x equals -83. So let's rewrite it. 7 minus 6x equals -83. All right, so again, peeling the onion, we'll start with the 7. So we're going to subtract 7 from both sides. And it's important to put the 7 underneath the 3 there. So these 7s kind of cancel out. We'll bring down our equal sign there, and so we have a -6x, don't drop that negative, -6x equals, and now we're really just adding because they're both negative. 83 plus 7 is 90, so 3 plus 7 is 0. Carry the 1, so 3 plus 7 is 10, and then 8 plus 1 is 9. But the answer is negative, so we have -6x equals -90. In order to get the x by itself, right now it's being multiplied by -6, so we're going to unmultiply it by dividing both sides by negative 6. Okay, so those negative 6's cancel out over here, leaving x by itself. X equals negative 90 over negative 6. And so we should divide 90 by 6, or we could reduce the fraction, however you want to go about it. You can actually see, if you can do it in your head, 6 goes into 9 one time with 3 as a remainder. Okay, that would make this 30. So then you'd have 1, and then 6 goes into 35 times. So that's 1, 5, 15. So 15 times 6 equals 90. So x should equal, since it's a negative divided by a negative, x should equal 15. But if you don't want to do it all in your head, you can just take 90 and divide by 6. Okay? So you don't have to know all the math in your head if you don't. 6 goes into 9 one time. 1 times 6 is 6. Okay, and we subtract. We have 3. We bring down the 0. 6 goes into 35 times. So there's that 15. And it's a negative divided by a negative equals a positive. So it's just 15. X equals 15. That's the answer. Okay. That is the end of number 30. Flipping the page over. More word problems. How old am I? Number 31. How old am I if 500 reduced by 4 times my age is 172? Well, this problem could be difficult if you now understand the word is means equals. All right, so does that help a little bit? And reduced, that means subtract, and then times means multiply. Okay, and my age, that phrase, my age, we'll call x. All right, so 500 minus 4 times x equals 172. That's how you convert words to an equation. So 500, it just takes practice. I had a real hard time with these word problems for years, and I still do, quite frankly. So don't feel bad. 500 reduced, so minus 4 times my age, 4x, equals, so is 172. All right, so we're going to solve this equation now. All right, step 1 is to go ahead and subtract 500 from both sides. But, yeah, I guess I'll just do it that way. I was going to do something else, but it might be confusing. So do 500, subtract 500, and subtract 500. That cancels out, leaving behind negative 4x equals. And now you have to take 500 away from 172, so you kind of have to flip it upside down and do the subtraction. So over here in side work, what we're going to do is we're going to do 500 minus 172. Okay, so I can't take 2 from 0. I'm going to have to borrow all the way over to the 5, make the 5 a 4, make this 0 a 9, and make this 0 a 10. So 10 minus 2 is 8. 9 minus 7 is 2. 4 minus 1 is 3. And the answer is negative. Negative 328. Negative 328. Now, I hope it's apparent to you that 328 is divisible by 4, because think about 32. What's 32 divided by 4? That's 8, okay? And then what's 8 divided by 4? 2. So already I know the answer is going to be 82, you know? But we'll go through the process because it's a negative divided by a negative. All right, so now we have negative 4 times x, so we need to divide by negative 4. What we do to the left, we must do to the right, both sides, to keep the equation in balance. So negative 4. These negative 4's cancel, leaving x all by itself, just what we wanted. X equals, and x, remember, x is my age. So my age equals whatever the quotient of 328 divided by and 4 is. So again, I already thinking 4 goes into 32 8 times, no remainder. 4 goes into 8 2 times, so 82. That's what I think it's going to be, but we'll go ahead and do this. 328 divided by 4. So 4 goes into 32 8 times. 8 times 4 is 32. There's no remainder, so we bring down the 8. 4 goes into 8 2 times. And you see there we got 82. So x equals 82. This person is 82. I suppose we should say age is 82 years. Okay, so whatever, x equals 82, age is 82 years. I'm fine with either. But there's 2 ways of saying that. All righty. Okay, number 32. Sarah Wong spent $31 on a magazine and 8 notepads. If the magazine cost $7, how much was each notepad? Well, you start thinking to yourself, okay, so they want to know about notepads, and we don't know what the notepads are. So the notepad is going to be X, the unknown thing. So 31 on a magazine and 8 notepads. And we know the magazines were $7. Okay, so put it like this. Let's call magazines let's see here. How do I want to do this? Oh, it was only one magazine, so we don't even need it as a variable. Okay, so here's how this is working. We have $7 for the magazine. So we just put 7 plus 8x, 8 notepads. Equals $31. That was the total, okay? So it's wanting to know how much was each notepad, okay? So I suppose the X is really, X is telling us how much was each notepad, the price. Okay, because really there was only one magazine and it was $7. Okay, so really it's kind of like 1 times 7 plus 1 magazine times $7 plus 8 notepads times some number of dollars equals 31. You see how that works? So now we're basically just going to be, I'm going to erase this. Okay, so we've got 7 plus 8x equals 31. That's our equation. We're going to start solving by subtracting 7 from both sides. Minus 7 minus 7. These 7's cancel out, and we have 8x equals whatever 31 minus 7 is. I can't take 7 from 1, so I'll make this a 2 and make this an 11. Okay, so now 11 minus 7, that's 4. 2 minus nothing is 2. Okay, I'm feeling good about this. 8x equals 24. Let's divide both sides by 8 to get x. And I believe we don't need to perform the long division. 24 divided by 8, that's one of our basic math facts. That's 3. So x equals 3, and so what we should probably write is each notepad cost $3. Okay, each notepad costs $3. All right. Well, word problems are nobody's favorite thing, but it really is satisfying to solve them. Okay, now these are fun problems. Number 33, this is going to be fun because you just plug in the numbers for the letters. I mean, it's pretty simple, folks. We're going to plug in 2 everywhere we see an M and 3 everywhere we see a P. All right, so I'm going to just do that right now. I'm going to say 5 plus, and now everywhere I see a P, I'm going to put a 3. So 5 plus 3 minus, and then there's an open parentheses, and then there's a P. So I'm going to put a 3 because P's are 3. Plus M, so I'll put 3 plus 2 all over 3. So that's I need to simplify that expression right there. We start with the parentheses. We do the parentheses first. 3 plus 2 is 5. So I'm going to write below here, I'm going to write an equal sign. We're going to do one step at a time so we don't make any silly mistakes. 5 plus 3. And then now I can drop those parentheses minus 5. Since the thing that I did is I added 3 plus 2. There's where that 5 comes from. I dropped the parentheses because I don't need them anymore. And there's the numerator. And here's the denominator. We can't cancel anything because we're adding and subtracting up here. Now we move from left to right. So 5 plus 3 minus 5, okay? 5 plus 3 is 8. 8 minus 5 is 3. Okay? And it makes sense because, look, 5 minus 5 is 0, so just cover up the 5 so you have nothing but 3 left. We can see where this is going. We have this equals 5 plus 3 is 8. 8 minus 5 is 3. So we're going to put 3 over 3. Well, whenever you have anything divided by itself, that's just 1. So 3 divided by 3 is 1. So this equals or simplifies to 1. All right. Okay. Oh boy, look at this. It looks really scary, but the numbers are small. No biggie. Okay, so everywhere I see an X, I'm going to put a 1. Everywhere I see a Y, I'm going to put a 5. So first there's the X, so I'm going to write 1 minus 2Y. Remember, Y is 5, and watch how I write this. I'm going to put minus 2, and then I'm going to put the 5 in parentheses. Now there's a reason I'm doing that. Parentheses means to multiply the number next to it. So those are still glued together by multiplication. So the Y became parentheses 5 parentheses. So now I got to write parentheses. Remember, parentheses means multiplication. And then X minus X, that's 1 minus 1. 1 minus 1. So there we go. Well, we're going to do the parentheses first. 1 minus 1 is 0. So this is equal to 1 minus 2 times 5 times 0. Okay, now let me explain something. 0 multiplied by anything is 0. So, but I'll just go ahead and show all the steps. 1, now I'll multiply this 2 and 5 together. 1 minus 10 times 0. Okay, well, 10 times 0 is 0. Negative 10 times 0 is 0. So this just equals 1. Okay, because it's 1 minus 0, which is just 1. So the answer on this one is also just 1. Okay. Whoa, look at all this. Okay, all I'm asking you to do is use your prime factor trees. And I give the prime factor numbers. There's a lot going on here, but I'm just asking you to prime factor. So we'll start here with number 35, and it's 340. So it's an even number, and so that means that 2 is a factor. Okay, so we do mental division here. 2 goes into 3 one time, leaving 1 as a remainder. 2 goes into 14 7 times, so it's going to be 170. Okay, but that's also an even number. That's not prime. The only even prime is 2, so we can again divide by 2 and do the mental division. 2 goes into 17 8 times, leaving 1 as a remainder. 2 goes into 10 5 times, so that's 85. And now I'm going to break this down. And now you want to check and see if this is divisible by 3 before you start dividing by 5. So the way you check that is say 8 plus 5 is 13. It's called the digital sum. 13 is not divisible by 3. So 85 is not divisible by 3. So move up to the next largest prime number, which is 5. Okay, so now I divide by 5. 5 goes into 8 one time, leaving 3 as a remainder, and so 5 goes into 35 7 times. So that's 5 times 17. 17 is a prime number. So they're all prime numbers, so we're done. These are all prime numbers. And so what we're going to do is we're going to write out the 340 equals 2 times 2 times 5 times 17. Okay? All right, now that's the factored form. That's what I wanted. The other way to write it is to say 2 squared times 5 times 17, and we're going to do that in the next section, but for here I wanted to see all the individual factors written out. So 2 times 2 times 5 times 17 is 340. All right, number 36. Okay, this is another easy one because it's even number. Start by dividing by 2. Well, look, I know 2 goes into 32 16 times, and it goes into 4 twice, so 162. Divide again by 2. Again, I can think quickly here. 2 goes into 16 8 times, and 2 1 time, so that'll be 81. And now you're tempted to divide by 9, but be careful. I want you to divide by the smallest prime number that this is divisible by. 8 plus 1. Do the digital sum. 8 plus 1 is 9. Is 9 divisible by 3? Yes, it is. That means 81 is divisible by 3. So resist the temptation to write a 9 on this left branch. Instead, write a 3. Now, 3 goes into 8 2 times, leaving 1 as a remainder. 3 goes into 8 2 times, leaving 2 as a remainder, and 21 7 times. So 3 times 27 equals 81. So now we're keeping our prime numbers in order. Now we take 27, again, add 2 and 7. 2 plus 7 is 9. 9 is divisible by 3, so I know that 27 is divisible by 3. And the cofactor will be 9. And I know what 9 is just 3 times 3. So you factor down to primes, okay? So that means all these numbers are prime. 2 times 2 times 3 times 3 times 3 times 3 equals 324, okay? That's what I mean by prime factoring. So 324 equals 2, there's 2 2s, so 2 times 2, and then there's 4 3s, so times 3 times 3 times 3 times 3. So this is your answer. I haven't been putting these in the red here. Put this in red, okay, and number 36. 2 times 2 times 3 times 3 times 3. I've lost count. There's 2 2s and 4 3s. All right, moving on. 296. This isn't that bad. Again, it's another even number, so we'll start with 2. And 2 goes into 28 14 times, right? Yeah, so that's 14, takes care of the first 2 digits, and that leaves 1 as a remainder, 16, 8, okay? So 148 times 2 is 296. Break it down again. And again, you should just see, well, that's 74, right? Because 2 goes into 14 7 times and 8 4 times. So 74. 2 times 74. You do that in your head, you can get fast. Again, 2 goes into 7 3 times with 1 as a remainder, so that's 14 7. Okay, 2 times 37. 37 is a prime number. It has no other factors, so we're done. It's just 2 times 2 times 2 times 37. So 296 equals 2 times 2 times 2 times 37. Okay, so this is how you write your answer. This skill of prime factoring is probably the most important skill that you learn in math. I can't think of anything more important, really. Let's go with 308. So that's going to be 2, and then I'm thinking like, so 15 times 2 is 30, and then 4 times 2 is 8, so 15, 4, 154. 154. Break that down. Well, 2 goes into 15 7 times. Leaving 1 as a remainder, 2 goes into 14 7 times, so 2 times 77. Break that down, and that's going to be 7 times 11, 2 prime numbers. So you're done. 2, 2, 7, 11. 2 times 2 times 7 times 11. Okay, so that equals 2 times 2 times 7 times 11. And that's it. That's 308. Prime factored. All right, moving on. This time we're going to do the same thing, only whenever you see multiple of the same number, you're going to use an exponent. So instead of 2 times 2 times 2, we would write 2 to the third, 2 cubed, okay? So that's just called the prime power factorization. It's really not that difficult at all. Let's just do it here. So this is 2 times 36. Which is 2 times 18, which is 2 times 9, which is 3 times 3. Okay, so you factor it down to primes first, and then you say, all right, 2, 2, 2. I got 3 2s. So that equals 2 to the third power. Okay? Now, how many 3s have I got? I got 2 3s. So that's 2 to the third power. Sorry, get camera here. 2 to the third power times 3 to the second power. Okay? And that's the same thing as writing 2, 2, 2, 3, 3. Just like you were doing before. Okay? Same thing, only this is the form called prime power factorization. So we'll put that in a box. No problem. 43. 43 is a prime number. So 43 equals 43. To the first, okay? So that's just 43. 43 is prime. We should probably write that. 43 is prime. There's nothing to do to it, okay? All right, that's number 40. Moving on. We got 2 more of these. 60. Still prime. We're still taking the prime power factorization. So we'll take 60, break it down. That's going to be, of course, 2 times 30, which is 2 times 15, which is 3 times 5. So I got 2 2s. So this is going to equal 2 squared times 3 times 5 times 3 times 5. All right? Simple as pie. Easy as pie. And moving on to number 42. This is the last one. It's 50. So that's pretty easy. That's going to be 5 times 10. And then we break that down. And that's 2 times 5. Okay? And I should have done that a different way. Now you see why I tell you I want you to start with the 2. Look. It's an even number, so I should have started with the 2, but my brain just, when I see 50, I think. But what if you did this? See, 2 times 25, right? That's still 50. Break the 25 down to 5 times 5. Now your factors are grouped together, makes it easier. So this is equal to 2 times 5 to the power of 2, or 5 squared, because there's 2 5s. Alrighty, and we're done with the factoring, and we're on 42, so we only have 8 left. Okay, find each product. Oh, this is easy stuff. My advice would be to rewrite this with the whole number as a fraction over 1, like that. So we'll just say, okay, so we have negative 2 over 1 times negative 2 over 3. Well, we got double negative, so that's going to be a positive number. Let's go ahead and multiply across the top and across the bottom. And there's nothing to reduce here, so it's just going to be 4/3. And I didn't specify whether to express this as a improper fraction or mixed number, so I'll just put an or here. I think this is pretty easy. 4/3 or 1 1/3. Okay, whichever. I'll take either. I'm not sure what Kuda wants, but there you go. Okay, so this one, you know what? We can actually just use the. Now we're going to rewrite it. 9 over 7, because I want to show you something. I want to show you something before I do this. So look at 9 and look at 6. 9 is 3 times 3. And 6 is 2 times 3. So just watch this. Watch this. This equals 3 times 3 over 7. You stay with me, okay? 9 is 3 times 3. So all I did is write 9 over 7. Now I write 3 times 3 over 7. I prime factored it. Now you're learning why prime factoring is so important. Times negative 7 over, now prime factor 6, 2 times 3. Now this is the cool part. This is why this is neat. You can look at diagonally, you can cancel anything that is the same. So I can cancel 1 3 here and here. Now look at this diagonally. I can cancel both of these 7s. These leave behind 1s. Okay? So now my life has just gotten really easy. Everything is gone except for the 3, the negative symbol, and the 2. So on top, I have negative 3, and on the bottom, I have 2. So it's negative 3 over 2. So we simplified it using prime factorization, made it really easy. Negative 3 over 2 or negative 1.5. Okay, whatever. Okay, now we're on to 45. Wants us to simplify. What I'm hoping that you do is prime factor this. It says show the GCF factor used to simplify blah blah blah. Okay, so let's prime factor both of these numbers, and I'll explain why we're doing this. So 126 prime factor 2 times, let's see here, 63. And that's 6 plus 3 is 9, which is divisible by 3. So I'm going to put a 3 here. 3 times 21. And then 3 times 7. Okay. So I want you to just leave that alone for a second. And now let's do 72. Okay, so 72, that's 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. Okay, there's the whole prime factorization. And now I want to show you what you can do with this if you're trying to find the greatest common factor. So prime factoring allows us to find all the factors, all the factor pairs. So like for 126, here are my factor pairs. 2 times 63. Then 2 times 3, which is 6, times 21. Then 2 times 3 times 3, which is 18, times 7. So the only other factor pair would be 1 times 126. So those are all the factor pairs. So those are all the factors of 126, not just the prime factors, okay? Because we're looking for the we're looking for the greatest common factor, okay? All right, so let's do it for 72, okay? So I've got 2 times 36. I have 2 times 2, which is 4 times 18. 2 times 2 times 2, which is 8 times 9. 2 times 2 times 2 times 2, okay? 8 times 3, which is 24 times 3. 24 times 3. Now, we can compare these two lists here. So look, I've got 263, 621, 18, 7. And down here I've got 236, 4, 18, 8, 9, 24, 3. What's the greatest common factor in both sets? 18, right? 18 is the greatest common factor in both sets. Now, so circle the greatest common factor in both sets down here. Yeah. And you already have the cofactor. So for 72, it's going to be 4, and for 126, the cofactor for 18 is 7. Now watch how cool this is. Since we know the GCF is 18, we can say that we're going to divide both the numerator and the denominator by 18. And we already know what the quotient is because we worked it out, you see? This is the magic. So for 126, I want to divide by 18. So what's left is 7. So up on top, for 126 divided by 18, that's 7. Over, go down to 72. Divided by 18, 4. Isn't that cool? That is cool. So that's 7/4 or 1 3/4. And it tells us to identify the GCF, so we should say GCF is 18. And you were only able to find that by prime factoring. So there's another reason why prime factoring is your best friend. Okay. Next, number 46. Okay, so we're going to prime factor 96 and 84 and find and then we're going to create all our cofactors. our factor pairs, and then we will compare. So first we're going to break down 96. It's even, so we'll start with 2 times 48, and then 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Okay, so I prime factored 96, and now I'm going to prime factor 84. Again, it's even, so life is easy. That's 2 times 42, which is 2 times 21, which is 3 times 7. Okay? Okay, so now we can write out our factor, all of our factors to try to find the greatest common one. So I got, for 96, 2 times 48, that's one factor pair. Then I got 2 times 2 times 24, so 4 times 24. Then 2 times 2 times 2, that's 8 times 12, 8 times 12. Now I got 2 times 2 times 2, that's 8 times 2, that's 16 times 6, 16 times 6. Now I got 2 times 2 times 2 times 2, that's 16 times 2, that's 32 times 3. So there's all the different factor pairs, okay? Each one of these multiplies to be, each one of these pairs of factors multiply to be 96, and that's all of them with the exception of 1 times 96. Moving on. I mean, actually, it's not all of them, I should say. There is double this number if you think of negatives. So negative 2 times negative 48, negative 4 times negative 24, negative 8 times negative 12, negative 16 times negative 6, negative 32 times negative. If I ask you to write out all the factors, you'd write those negatives. And that does become very useful later on, but for now, this is good, okay? But just don't forget about negative land. Okay, so looking up here, for 84, now I've got 2 times 42. And then 2 times 2 times 21, so that's 4 times 21. And then I got 2 times 2 times 3, so 4 times 3 is 12 times 7. And that's all of them, okay? So now what I want to do is I want to scan both lists to look for the greatest common factor. Okay, so just take a look here for a minute. Let it seep in. 2, 42, 4, 21, 12, 7. 2, 48, 4, 24, 8, 12, 16, 6, 32, 3. I'm thinking it's 12. Look at both lists. The biggest number in both lists is 12. So our greatest common factor is 12. Circle the GCF. Okay. And you already know the cofactor, right? So you know that when you divide 96 by 12, you'll have 8 left over. And when you divide 84 by 12, you'll have 7 left over. So you already know it's 8/7. Isn't that cool? I mean, that should just shock you. Okay? So we're going to divide the top and the bottom by the GCF of 12. This is really powerful stuff, guys. All right, so we already know 96 divided by 12, or make sure we're looking at the right list here. 96 divided by 12 is 8. So right here, we're going to put 8 in the numerator over. And then for 84 divided by 12, I just go down here. Look at this 12. There's my other factor, 7. So that's the thing to put here. So easy, so fun. So 8/7 or 1 1/7. And then we should say, because it asks us to identify the greatest common factor, GCF is 12. Okay, so that's how I would answer that question. And let's put that sucker in a box of correctness, a red box of correctness. You know what? I'll get you guys these. These are very cool. These are Japanese pencils, and they really hold a good point. You can buy these red and blue pencils here in America, but the lead is like crayon lead, and this is like real lead, like a pencil, but it's colored. So it's different than colored pencils that you can buy. So I'll get you guys some. So you've got the red and the blue. You can. All right, look at this. We've made it to the last page, the back page. And you know we're working hard when we've pressed so hard down on the paper with pencil that it's bleeding through. Okay, now this is, I make it, I put a lot of, this is to teach you how to do this if you can't remember. With scientific notation, the easiest part is the powers of 10. You just add the exponents. Okay, so whatever you get, it's going to be 10 to the negative first power. Okay? Because negative 3 plus 2 is negative 1. Now, what you do with the 7.2 and the 8.9 is you just multiply 7.2 times 8.9. So let's do that. 7.2 times 8.9. There's our problem. Okay, here we go. Ready? 2 times 9 is 18. Write the 8, carry the 1. 7 times 9 is 63 plus 1, 64. Okay, ready? Round 2, row 2. 2 times 8 is 16. Write the 6, carry the 1. 7 times 8 is 56 plus 1, 57. Okay, you can put a 0 there if you want. Now, we're going to add these up. 8 plus 0 is 8. 4 plus 6 is 10, carry the 1. 6 plus 7 is 13, plus 1 is 14, put a 4, carry the 1. 5 plus 1 is 6. Now, if you read this huge paragraph, it tells you that when you're doing scientific notation, you must express the result with the same number of significant digits used here, and you can only have one number to the left of the decimal. So if you look here, I've got 1, 2. I need to move the decimal place 2 places, which is good news. Okay? But that's not all. That's not. So let me explain. So now we have 64. I'm going to explain everything. 64.08 times 10 to the negative first power. But remember what I told you. I said you have to have the decimal right there. Okay? So it's 6.4 and because we moved the decimal point one place to the left, we need to increment our exponent, okay? So now we're going to write 6 6.408 times 10, and it needs to be able to go back and so because we moved to the left, we're going to add 1 here. So -1 plus 1 is 0, okay? 6.408 times 10 to the 0. Now, a fact that you need to learn is that anything, I'll just write it out, anything raised to the power of 0 equals 1. Okay, so that's just 10 to the 0 power is just 1. So the answer, remember, we're only going to put it to this 1 digit. The answer, the way this works out, is this is just 6.4. Even if you were to round this 8 and make this a 6.41, you only have these 2 digits to work with here. Okay, so it's 6.4 times nothing, times 10 to the 0, which is times 1. Okay, so the answer is 6.4. And if there's something different, I'm not entirely sure if CUDA is going to handle this differently. It might handle it with the 64.08, in which case it probably says 64.1 times 10 to the negative first. So I'll just put a blue box around all of this, because it all depends on how the computer is doing it. And the scientific notation stuff can get a little confusing. So what I'm really looking for is that you're able to multiply all this together and work with these exponents. Let's move on. Okay, number 48. So we see -2 plus 0 is -2. So 10 to the -2 is going to be our answer. And we're going to multiply 5.8 times 4. Okay, so this one looks like it'll be a little simpler. 8 times 4 is 32, carry the 3. 5 times 4 is 20 plus 3, that's 23. And that's it, so we're going to take the decimal point and move it over 1 place. And so, yeah, here we go again. I'm not sure what CUDA is going to say. It's 23.2 times 10 to the -2, or 2.3 times 10 to the -1. Okay, I'm not sure how it's going to handle it, so I'll just leave it both ways. One of these two is fine. Okay. All right, so here we are on the final 2 problems. Percent change rounded to the nearest tenth of a percent. State if it's an increase or a decrease. There were some folks that said they had a hard time understanding percent change, but there's an easy way to do it. Just think about the numbers and figure out what's the new number and what's the old number. And then it's new minus old over old times 100, and that'll turn it into a percent. New minus old over old times 100. New minus old over old times 100, okay? Now take a look here at number 49. From 52 to 17, so which is the new number and which is the old number? Well, the new number is 17. That's the new number. And 52 is the old number. So we're going to do new minus old over old times 100, okay? If you have, you're going to end up with like a negative, okay? Because it's a decrease. Because it's obviously it's a decrease. It's going from 52 to 17. But just remember, new minus old over old. So it's the way you set this up is 17 minus 52 over 52 times 100. Okay. Now once you figure this out, you'll have it solved. So first we got to subtract 52 from 17. So that's going to be a negative number. We'll do 52 minus 17 over here. Okay, so we're going to borrow here, make this a 12. 12 minus 7, that's 5. 4 minus 1 is 3. But it's negative, so that's going to be negative 35. Okay, so I have negative 35 over 52 times 100. Okay. And so we have to get this, we have to figure out what this is as a decimal. So we have to divide 35 by 52. And so we can get to the 10th of a percent. All right, so let's just take 35. And you know you're going to have to write out a much longer division bar, right? Because you're dividing by 52. So right away, it won't go in. And so you got to invent a zero and say, okay, now how many times will 52 go into 350? Well, the way I would look at this is I would say, well, how many times would 50 go into 350? Let's see, 50 goes into 35 7 times. So maybe 6, because 52 is bigger than 50. Maybe 52 times 6. Let's see what that is. You know, you're kind of guessing. But it's an educated guess. 52 times 6. It should be a number less than 350, but not more than 52 less than 350. So that's 1231, 312. Yeah, we're definitely in the ballpark there. So the first number is 6, and 6 times 52 is 312. Okay. So let's figure that out. We'll borrow from the 5, make that a 4, and make that a 10. And then 10 minus 2 is 8. 4 minus 1 is 3. So we'll invent another 0 and do 380. Okay? Well, actually, I don't think anything changed because it's still going to be 6. Right? Because 7 times 52, well, no. Maybe it's 7. Let's do 52 times 7. I bet it's 7. So 52 times 7. Remember, we want to get as close to 380 as possible without going over. So that's 14, carry the 1, 35, 36. Yeah. Okay, 364. We're good to go. So put 6, 7. All right, so that's 364. Okay, borrow here, make this a 7, make this a 10. Sorry, you can't see. Okay, and then we have 10 minus 4 is 6. 7 minus 6 is 1. And now we'll invent a 0. There we go. We just need to do this a couple more times. So 52, well, think about 50. 50 goes into 150 3 times, okay? So I bet 52 will go in 163 times, right? Because that's 52 times 3. See, 52 times 3 is the same thing as like 50 times 3 plus 6. So it should be 156. Yep, it is. Okay. So we'll put a 3 here. So 0.673. multiply 3 times 52, that's 156. And we're left with 4 and 0, 0. Now 52 won't go into 40, so we're going to put a 0 there. And then we have 400, right? Well, 50 goes into 400 8 times. So we'll just back off 1 and say 7. We don't even have to check it. And there's your quotient, okay? So now, take that number, 0.67307, and multiply it by 100. And the way you do that is you just take your decimal point and move it 2 places to the right. Okay? So you got 67.3. And remember, it said round to the nearest tenths place. So look at the 3 and look at the number to the right of the 3. It's a 0. So you're not going to round the 3 up. So it's 67.3 as a percent. And so the answer is 67.3% decrease. Okay? Because this quotient down here, remember we were dividing by negative 35, so that's really negative 0.67307. But we don't need to write negative 67.3%, as long as we write a 67.3% decrease, because the word decrease is kind of in place of writing the negative symbol. Okay, like for example, an alternative way to write this would be negative 67.3% change. Okay, but the question asks you to use the decrease, increase verbiage. So this is actually what we want to write. Okay. That was cool. Moving on to the final problem, number 50, from 49 to 84. So we already know that it's going to be an increase. Okay, so we're going to have positive numbers. Now, what's new and what's old? From 49 to 84. So 84 is new, and 49 is old. And remember, new minus old over old times 100. So we're going to write 84 minus 49 over 49 times 100. Okay? There's your answer. Now we just have to compute it, okay? By hand without a calculator. So the first thing we're going to do is do 84 minus 49 and see what that is. So I'm going to have to borrow, make this a 7, make this a 14. 14 minus 9 is 5. 7 minus 4 is 3. So I end up with the same thing. 35, not negative 35. Just 35. But I had 35 in the last problem. Okay, so now this equals 35 over 49, okay, times 100. So we're going to have to divide 35 by 49 out to like 4 decimal places, and then we'll turn it into the percent, and then we'll be done. Okay, we'll be done with the whole thing. All right, so let's get this division going. We have 35, and we can already guarantee that it's going to go out a long way. And then we put 49 here. Well, good thing is 49 is really close to 50, right? So I'm going to put a decimal point and invent a 0. And think about this. 50 goes into 350. 50 goes into 350 7 times. So 49 will go into 357 times. Okay, do you see the mental gymnastic? You just intuitively understand it's 1 less than 50. If 50 will go in 7 times, 49 will. Okay, but to figure out what 49 times 7 is, that's a different story. So I always like to do the work. That's 63. 28 plus 6 is 34. 343. Oh, really close to 350. Cool. 343. And 350 minus 343, that's just going to be 7 left over. So invent a 0. 49 will go into 70 one time, because if it was 2 times, that would be more than 70, right? So it'll go in 1 time. Easy math. And we put a 49 here. Thank your lucky stars for that one. And 10 minus 9 is 1. 6 minus 4 is 2. 210, okay? Again, think about 50. 50 will go into 21, or 5 will go into 21 4 times. So 50 will go into 210 40 times, or 4 times. And so the numbers, what I'm getting at here is it'll go in 4 times, right? So 4. So 49 times 4 should be close to 210, but not greater than 210. That's 6, 3, and then 16 plus 3 is 19, 196. Perfect. So we got 196. And what's the remainder there? I mean, we can go ahead and compute it. So it's 10, 10. So that's going to be 4, and that's going to be 1. 14. And let's do one more. 140. Okay, so how many times will 50 go into 140? Well, it won't. It's going to go in twice. 49. Will it go in 3 times? Let's see. 27. See, put a thing like this. 49 can also be thought of as 40 and 9. And so if you want to know, like, 9 times 3, that's 27. 40 times 3 is 120, plus 27, that's 147. That's too big. So 3 is too big, so it's going to be 2. Okay, 2 times 49. 49 times 2. You got 18, 98. Okay, 98. And we really don't have to do this. We're done. But since we're so close, I just thought I'd finish it off. It's going to give us 2 and then 4. See, that the remainder is 42, so we couldn't have fit another one in. All right, we got enough digits, though. Are we going to need to round? No, we're not going to need to round. So we're just going to move this over 2 places. So 71.4, round to the nearest tenth, 71.4% increase. Okay, 71.4% increase. And that's it. That's the end. 50 problems. Okay. So that took, I don't know how long it'll be in the final cut, but I started working on this at like 3:30 and it's 7 o'clock. 2.5 hours. I'm still at school, by the way. So, yeah. So if I started at 3:30 and it's 7 o'clock now, that's a half hour, gets me to 4. 4 to 5, 5 to 6, 6 to 7. No, 3.5 hours. Took me 3.5 hours. I think that's right. I'm so exhausted, I can't even think straight. It took me a long time. Listen, I hope this video was helpful. One of the reasons why I do these videos is I want my students to know that I'm not going to give you anything, an assignment that I am not myself going to sit down and do. So, that's kind of like Alexander the Great. I mean, I'm not comparing myself to Alexander the Great, but just take this story, okay? Alexander the Great was famous for going into battle with his armies. He would go fight too. And then there was another general that fought for a country called Carthage, and they were the enemies of Rome. And their general was called Hannibal. And like Hannibal Lecter, that's where that comes from. And Hannibal, the general of Carthage, was famous for actually, instead of resting at night in like a palace or a big tent that they build for the emperor, he would go sleep on the ground outside, get all bit up by mosquitoes and stuff with his army, with his men, with his soldiers. And so I just want you guys to know, if I'm the general and y'all are my soldiers, I'm out there on the battlefield fighting with you. And if you guys have to sleep out in the cold, I'm also going to jump out there and sleep out in the cold. So in other words, what I'm trying to say is, here's video evidence that I put in the time to do these problems, just to show a little bit of solidarity and teamwork and team spirit with you folks, because I know that you have a lot to do as well. But at least this should give you some motivation, and hopefully, if you can't figure out some of these problems, when you watch this, it'll actually teach you a little bit about how to do this math. I know it's not simple, guys, but I'm really proud of you, and just keep your head in the game, keep showing up, and I promise I will, never leave a fallen man behind. Of course, that by man, I mean woman or anybody behind. So thank you for watching. Please like, subscribe, comment, hit that notification bell so you're always get notified when I release new videos on this channel. Thank you very much.